The slope of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. If you have 2 points, you can label them x1, y1. The ones simply mean the first point, and x2, y2, the second point. And the slope formula is y2 minus y1, the vertical change, over x2 minus x1, the horizontal change. If a line has positive slope, it rises from left to right. If a line has negative slope, it falls from left to right. A line with 0 slope is a horizontal line, and a line with undefined slope is a vertical line. Horizontal lines, when the slope is 0, that happens when you end up with 0 divided by a number. 0 divided by anything is 0. I have 0 cookies in my hand. See my 0 cookies? 0 cookies in my hand. I'm going to divide these 0 cookies among all of you. How many cookies are you going to get? 0. 0 divided by anything is 0. A line with undefined slope. Undefined slope happens when you have a number divided by 0. The number 1 rule in math is you cannot divide by 0. It's impossible to even fathom how that would work. It doesn't exist. It creates an undefined scenario. Okay, next page. Okay. Parallel lines. Lines are parallel if and only if they have the exact same slope. So, if the slope of line 1 is 3, what would the slope of line 2 have to be in order for the lines to be parallel? 3. Perpendicular lines, I'm going to set up a little table, original and perpendicular, so we can make sure we know how perpendicular slope works. Lines are perpendicular if and only if their slopes are opposite reciprocals of each other. Opposite means one of them positive, one of them negative. Reciprocals means you take the fraction and you flip it. So say our original slope was positive 2/3. What would be the perpendicular slope? Negative 3/2. Let's say our original slope is negative 1/3. What would be the perpendicular slope? Positive 3/1, which is simply 3. And let's say our original slope is positive 2. What would be the perpendicular slope? Negative 1/2. Okay, now the tricky one. You ready for the tricky one? Our original slope is negative 1. Positive 1. Negative 1 and positive 1 are perpendicular. Okay, you ready for another challenge? Let's say our slope is 0. 0 is a horizontal line. What's perpendicular to a horizontal line? Vertical line. And what's the slope of a vertical line? Jalen's got it. Undefined. All right. We'll get into parallel and perpendicular down in example like 6 or something. So example 1, a skateboard ramp has a rise of 15 inches and a run of 54 inches. What is the slope of the skateboard ramp? This is simple, rise over run. The skateboard ramp has a rise of 15 inches and a run of 54 inches. Simplify that fraction. What do you get? 5/18. For numbers 2 through 6, we're actually going to do number 4 together, and I'll have you try 2, 3, and 6, or 2, 3, and 5 on your own. This is using the slope formula, y2 minus y1 over x2 minus x1. The biggest mistakes I see with the slope formula are involving the subtraction. If you are subtracting and your x or y value is negative, you may have instances where you have to do minus a negative. That is okay. The negative in the point does not take the place of the subtraction. You would have to do both of them. The other problem I see is people trying to do their subtraction in the opposite directions. So say you do, why did you just jump? 1 minus a negative 2. That's subtracting our y values. 1 from the second point minus negative 2 from the first point. Because we started with the second point, when we subtract our x's, we also have to start with the second point. So 6 minus a negative 3. What is 1 minus a negative 2? 3. And 6 minus a negative 3. And that simplifies to 1/3. Now, does that slope rise, fall, horizontal, or vertical? Yeah, you're right. It rises. It's positive. It rises. Good job. Okay, try 2, 3, and 5 on your own. So number 2, you would do 3 minus 3 over 4 minus 0, which is 0 over 4. That is a slope of 0, which means it is a horizontal line. Number 3, you would do negative 4 minus 1. Now, that is negative 4 from the second point minus 1 from the first point over 1 from the second point minus a negative 5. That gives us negative 5 over 6. That is a negative slope, so that line falls. And our last one, 7 minus 3 over 7 minus 7. 4 divided by 0, which is undefined, and that is a vertical line. Okay, we're going to find a whole bunch more slopes because now we have to find the slope of line 1, slope of line 2, and compare them to decide, are these two lines parallel, perpendicular, or neither? So take a moment and find the slope of line 1, the slope of line 2 for number 6. If you get done with that, find the slope of line 1 and line 2 in number 7. And we'll talk about it in a second. Okay, number 6, we got negative 3 and 1/3. That would be perpendicular slopes. Number 7, 0 divided by 9 is 0. 2 divided by 0 is undefined. So we have a horizontal line and a vertical line. Those are also perpendicular. Okay, if you haven't already, turn to the next page. There's one more of these. What are you guessing it's going to turn out to be? Probably parallel, but we'll see. Maybe it's not. So turn to the next page and try number 8. Okay, so I got negative 5 over 4 for line 1 and 5 over negative 4 for line 2. What does that mean? Parallel. So it doesn't matter if the negative is on the bottom. As long as there's only one negative in there, it's a negative slope. So negative 5 over 4 and 5 over negative 4 are the same thing. And those two lines are parallel. Okay, a real-world use of slope. Whoops, there goes my calculator. The slope of a road, or the grade of a road, is usually expressed as a percent. If any of you have driven in the mountains in Colorado and there's those signs like 4% grade ahead, they're talking about the slope of the road. Because if a road is too steep, large trucks, campers, motorhomes, even some vehicles might have trouble either getting up the hill or going down and using your brakes too much and then your brakes failing, and that can be a really, really scary thing. So, for example, if a road has a grade of 3%, that means it rises 3 feet for every 100 feet of horizontal distance. Find the grade of a road that has a rise of 75 feet over a horizontal distance of 2,000 feet. This is, again, a simple rise over run. So it rises 75 feet over a horizontal distance of 2,000 feet. Now, because this is a percent, we can write this as a decimal. So what is this decimal? 0.0375. Because this is a decimal, to change it back into a percent, You either move the decimal point 2 places to the right or multiply it by 100. This is 3.75%. So the grade of the road would be 3.75%. Okay, for part B, do you remember proportions? We're going to use proportions to help us solve example B. Find the horizontal length x of a road with a grade of 4% if the road rises 50 feet over that length. So 4% we know is rising 4 feet over a 100 feet horizontal distance. We want to find the horizontal length, horizontal's on the bottom, so x goes on the bottom, if the road rises 50 feet. So we're just setting up, this is the vertical rise, this on the bottom is the horizontal run, and using 4 out of 100 as 1/2 of our proportion, and then matching that up with 50 over x. How do you solve a proportion like this? Cross multiply. So 4 times x equals 5,000, and 5,000 divided by 4, 1,250 feet. Don't forget your label. So this road that rises 50 feet over 1,250 feet, which gives it a grade of 4%. And I think there's actually like rules and regulations. If you want to be considered an interstate, you have to have all of your grades under a certain amount. Otherwise, you can't be an interstate. Okay, number 10 is another way that slope and rate of change are used. The number of U.S. cell phone subscribers increased from 16 million in 1993 to 44 million in 1996. Find the average rate of change and then use it to estimate the number of subscribers in 1997. Yes. Okay, well, let's think about, would years per subscribers make more sense, or would prescribers per year, not prescribers, subscribers, would it make more sense to do years per people or people per years? People per years. So we want to do subscribers per year. So for subscribers, we need to subtract the years. How many years are they talking about here? From 1993 to 1996, how many years is that? 3 years. And you can do that by doing 1996 minus 1993. So that's 3 years on the bottom. Subscribers. In 1996, there were 44 million. In 1993, there were 16 million. So how much did that increase? What is 44 minus 16? 28. So 28 over 3. Now, because this is a real-world situation, decimals are totally fine, and it'll make the situation make more sense. So what is 28 divided by 3 as a decimal? 9.3 repeated. So we are increasing by approximately 9.33 subscribers per year. Random numbers on the paper tend to be confusing. If you can write some words next to those to help it make more sense, that's going to help you. So if we're increasing by 9.33 subscribers per year, in 1996 we have 44 million. 1997 is one more year, so we would need to do 44 million plus 9.33 million subscribers per year to get 53.33 million, it's technically million, subscribers per year.